Okay, so we're going to do complex circuits today, and I have multiple pen colors to go through all of this with you. And I'm going to go through two examples. So complex circuits are when you are mixing series and parallel in one circuit. And so the math is the same. I mean, you're still doing series and parallel math, but you have to interchange them when necessary. So just as a reminder, if you're looking at your formula sheet with me, so at the bottom, third row from the bottom, this is series formulas. Second row from the bottom, these are parallel formulas. And then Ohm's law, V equals IR, we're going to use that over and over and over as well. Okay? So those are your formulas. Okay, so here is a typical complex circuit. You can pause the video to draw things as necessary. It's up to you. So what do we have? Well, let's fill in everything that we have in our chart. So here I have a battery with a voltmeter attached to it. My voltmeter says that it's 12 volts. So I'm going to put that in my chart. That's 12 volts. And then resistor number 1 is in series with the battery, and it's 10 ohms. Resistor number 2 is in parallel to the battery, and it is 5 ohms. Resistor number 3 is parallel to resistor number 2 and the battery, and it's 8 ohms. And resistor number 4 is in series with the battery, and it is 6 ohms. Okay, so there's a couple of ways to attack this. I'm going to show you two different ways. So for this first one, I have a section that's parallel, right? So I'm going to put a little box around it and just say, okay, well, this is parallel between 2 and 3. So I'm going to put a box around that in my chart as well. And I can only do parallel math inside of the box. This is the parallel portion. I'm going to add a row to the table for parallel math. Okay, so I can only do parallel math on that part. So let's see. So I have these two are in parallel with each other. So my resistance on the parallel portion is going to be 1 over 5 plus 1 over 8, and then the reciprocal. Okay, and you get about 3.1 ohms. So that's 3.1 ohms. Okay, so this box that I've drawn, this is in series with the battery. So the two resistors are in parallel, but the box itself is in series. So now I'm going to go back to series math, and I can find the resistance on the battery. So that's using series math, so I just add up the 10 plus the one I just found on the box, 3.1, plus the R4 because it's in series with the battery. So 19.1 ohms. So my R total is 19.1 ohms. Okay, so now I've got 2 out of 3 in that row, so I can find the current on the battery. So using Ohm's law, V equals IR, so I equals V over R. So 12 divided by 19.1. 0.63 amps. So that's the current on the battery. Current is uniform in a series circuit, so all the things that are in series with the battery also are 0.63 amps. So resistor number 4 is in series, so it's 0.63 amps. Resistor number 1 is in series, so it's 0.63 amps. And the pink box that I made is technically in series as a combination with the battery. So that is 0.63 amps. So now I can find the voltages on my resistor 1, 4, and the parallel portion. So V equals IR. So for resistor 1, 0.63 times 10, which is 6.3 volts. Resistor number 4 0.63 times 6. So about 3.8 volts. And the parallel portion, 0.63 times 3.1. And it's about, I'm going to go with 1.9. I think that'll make my math work a little better. I rounded the other two up, around that one slightly down. All right, so 1.9 volts. Now, for the parallel portion of my circuit, the voltage is uniform. So that means the voltage on resistors 2 and 3 are also 1.9. Okay. And if I want to check and make sure that this is right, then my total voltage, I didn't really use that equation. So my total voltage on the battery would be equal to the sum of the voltages across resistor 4 and 1 and the box. So let's see what those are real quick. So that would be 6.3 plus 3.8 plus 1.9, and it's 12. So we must have done that correctly. So you can just kind of double check as you go to make sure that you have the right numbers. That way if you get stuck, you can fix it real quick. All right, and then the last portion that we need to find is the current on resistors 2 and 3. And current, as we said before, is equal to V over R. So for resistor number 2, that would be 1.9 over 5, which is 0.38, or yeah, do 0.38 amps. And for resistor number 3, it would be 1.9 divided by 8. And it's about 0.24. Okay, if we wanted to double check and make sure that's correct, if we add those two together, it should equal the current on the parallel portion. So let's see, so 0.38 plus 0.24, and we get 0.62. 0.63 is close enough. So, okay. So that is one method for completing complex circuits. So let's do another one, and the next one I drew is very, very elaborate. So you are definitely going to want to pause the video to write down your circuit. And this is where I'm really going to go crazy with the colors. Okay? Okay, so let's write down everything that we know about our circuit. So I have a battery, and it's got 30 volts on the voltmeter. So I don't know if you can see my table here. The new bells suck. So this is 30 volts on the battery. My resistor number 1 is 5 ohms. Resistor number 2 is 6 ohms. I can't show you the whole thing with the table, sorry. Resistor number 3 is 3 ohms. Resistor number 4 is 4 ohms. Resistor number 5 is 6 ohms. And resistor number 6 is 5 ohms. Okay. So you have 2 resistors in series with each other, but then those as a combination are in parallel to resistor number 2. So I'm going to try different colors here. So I'm going to put a green box around my series portion. And like I said, this is within a parallel portion. So I'm going to put a brown box around that. Okay. And then I've got a portion of my circuit over here, resistor 5 and 6. These are also in parallel with each other. So I'm going to put them in a pink box. So this box is in series with the brown box, which is in series with resistor 1, which is in series with the battery. So you have a parallel portion within a series circuit, and you have another series circuit within a parallel circuit within a series circuit. So you might want to try something a little different with elaborate ones like this. So what I normally do is I color code them, and then I have a I will have a VIR for each of my colors. Oops. And this is why I have whiteout. That doesn't work as well on yellow paper. Fun times. And the pink one. And put it off to the side over here. Okay. So first I'm going to start with the series. I can find my total resistance on the series green portion, right? Because it's just 3 plus 4, so that's 7 ohms. Then I can find the parallel portion because this as a combination is 7 and this is 6 and they're parallel to each other. So I'll switch to brown over here. So then I would have 1 over 7 plus 1 over 6 and reciprocate. So 1 over 7 plus 1 over 6, reciprocate. There we go. All right, so it's about, let's go with just 3.2 is good enough for me. Ohms. Okay, and then my pink portion, I have 5 parallel to 6. So 1 over 5 plus 1 over 6 and reciprocate. So about 2.7. Okay, so now I can find our total on the battery because it's the sum of R1 plus the brown box plus the pink box. So, do purple. So our total is going to equal 5 plus the brown box, which was 3.2, plus the pink box, which is 2.7. So that's what, 8.2, 10.9? Yeah, that's about 10.9 ohms. So that's my R total. Okay, so now I've got my R total and my V total. I can find my I. So I is V over R. So that's 30 over 10.9. So about 2.8 is good for that one. Okay, so now that I have the current on the battery, anything that's in series with the battery has the exact same current as the battery. So R1 is in series with the battery, so it has a 2.8 amps current. The brown box is in series with the battery, so the brown box current is 2.8 amps. The pink box is also in series with the battery, so its current is 2.8 amps. Okay, so now I can use Ohm's law to find the voltage on resistor number 1, the brown box, and the pink box. Okay, so resistor number 1, right? So V equals IR. So this one, oh, you can't see that. Sorry, V equals IR. So you have 2.8 times 5 So that's 14 volts. And then let's see the brown box. So that one we have 2.8 times 3.2. Okay, so that gives us about 9.0. And then the pink box, we have 2.8 times 2.7, which is about 7.6. Let's go with that. Okay. Okay, so oops, here we go. Okay, so voltage is uniform in parallel circuits. So if the voltage on the pink box, let me do the pink one. If the voltage on the pink box is 7.6, then the voltage across resistor 6 and resistor 5 is 7.6 volts. So we can add that into our chart. So resistor 5, the voltage is 7.6 volts. Resistor 6 is 7.6 volts. Okay, because they're in the pink box, that's why I switched to pink, so you can kind of keep up with my color coding. Okay, now the brown box, the voltage is 9 volts. Well, resistor 2 is in parallel to resistors 3 and 4 as a combo, the green box. So the voltage on resistor 2 is 9 volts. And the voltage on the green box is also 9 volts. So now we can find the current on the green box. Okay, so I'm going to scroll down here. Oh, actually I can just do it right there. So I equals V over R. So that's 9 over 7. So that's about 1.3 amps. Okay, so that means the current on both the things in the green box are the same. So the current on resistor 3 is 1.3 amps. And the current on resistor 4 is also 1.3 amps. Okay, so now at this point in our table, we just have a few things to fill in. So I have resistor number 2, I need current. And resistor 5 and 6, I also need current. So I equals V over R. So for resistor number 2, that's 9 over 6, which is what, 1.5, I think? Yep, 1.5. All right, so that's 1.5 amps. Okay. And then for resistor 5, it's 7.6 over 6. So about 1.3. And for resistor 6, 7.6 over 5. So that's about 1.5 amps. Okay. And I can kind of double check that. Actually, I can kind of stop for a second and say, okay, so if I add up the current on resistor 5 and 6, I should get the overall current on the pink box, right? So 1.3 plus 1.5 is 2.8. The current on the pink box was 2.8. So I'm still doing good with my math, okay? And so then I just have one last thing to do, and that's to find the voltage on 3 and 4, okay? And they're inside the green box. I'm going to switch back to green. Okay, and so V equals IR. So for resistor 3, that would be 1.3 times 3, which I believe is 3.9. Yep, 3.9. And resistor 4, 1.3 times 4, which I believe is 5.2, but let's just see. Yep, 5.2. Okay, and if I were to add up those two voltages, they should equal the total voltage on my green box, which was 9. And so 3.9 plus 4.2, that's like 4.0 plus 5.1, which is about 9.1. That's close enough to 9 to say that that's right, okay? And so that's another method to do complex circuits. So pick one of those methods. You have a sizable amount of homework with regards to how many complex circuits that you have. But just show your work, do your best. Yeah. Let me know if you have questions. Good luck.